Question 9. Ammonia is used to make synthetic fertilizers. Ammonia is made by the Haber process. So we've got this reaction here happening in the Haber process. Nitrogen plus hydrogen makes ammonia. The reaction in the Haber process reaches equilibrium. Describe the rates of the forward and reverse reactions at equilibrium. So obviously at equilibrium, the rate of the forward reaction is equal to the rate of the reverse reaction. So that's all you need to say for this one mark. Or you can just say they are both the same. Part B. The graph shows the effect of temperature and pressure on the yield of ammonia in the Haber process. So we've got the pressure in megapascals on the x-axis, the yield, how much ammonia they're making, the percentage yield of ammonia on the y-axis, and we've got the key here, so each of these different lines are for the different temperatures that it happens at. So, part I, state the lowest temperature and pressure necessary to get a yield of ammonia of 15%. So we need the temperature and the pressure in megapascals. The yield of ammonia at 15, so each 5 squares is 10, and therefore 15 would be somewhere here, wouldn't it? So 15%. So you draw a line across to one of those curves. Now we're looking for the lowest temperature, so this bold line is actually the lowest temperature. Where it touches that, you're going to start going down from there, and that is roughly about, so what pressure is this? It's about 1.5 megapascals, because each small square is 1. We've got here 10, so each small square is 1, and therefore it's 1.5 megapascals. The lowest temperature obviously is 350. So 350 degrees Celsius and 1.5. Now the examiner would allow you to have this answer a bit lower or a bit higher because of the error that can happen when you're reading from the graph, but it should be around 1.5. Suggest one disadvantage of using a temperature of 350 degrees Celsius rather than 450 degrees Celsius in the Haber process for 1 mark. And obviously if you're using a lower temperature, the rate of reaction will be slower. So that's the reason. The rate of reaction would be slower. So part I. A reactor starts with 12 tons of hydrogen and excess nitrogen. So this is the equation, the symbol equation for the reaction in the Haber process. How many tons of ammonia would be produced from 6 times 10 to the power of 6 moles of hydrogen, H2? We're given this key here, or this conversion. 1 ton is equal to 1 times 10 to the power of 6 grams. Use the equation, number of moles is equal to the mass divided by the relative formula mass. So we need to work out the mass of ammonia, the tons of ammonia. Now mass, we just need to rearrange this equation because this is number of moles. So mass is equal to moles times by the relative formula mass. Now I've left this space here because I want to show the numbers, the working out at the bottom. So let's start with the relative formula mass first. The relative formula mass is the mass of the formula of ammonia. So nitrogen has a mass of 14, relative mass, and hydrogen has a relative mass of 1, but because there's 3 of those, it's 3 in total, and therefore the relative formula mass of NH3 is 14 plus 3, which is 17. So that's 17. The number of moles, we haven't been given the specific number of moles, but we can use the number of moles of hydrogen to work out the number of moles of ammonia using this molar ratio. So we've got 1 mole of nitrogen, 3 moles of hydrogen, and 2 moles of ammonia. But we're only concerned with these two because we're given this one, hydrogen, it's 6 times 10 to the power of 6, and we're using that to work out this one. So the ratio of hydrogen to ammonia is actually 3 to 2. Okay, so that ratio is 3 to 2. So for every 3 moles of hydrogen, we have 2 moles of ammonia. So to work out the number of moles of ammonia, it's actually 2/3 of that of hydrogen. Okay, so of is usually a times, so 2/3 of whatever the moles for hydrogen is, so which is 6 times 10 to the power of 6. Okay, so all of this is your moles, will give you your answer for your moles of ammonia, and obviously we times that by the relative formula mass 17 to give us the mass. Okay, and if you type that into the calculator, you'd get 68 times 10 to the power of 6 grams. Okay, in the calculator it might just have 6 zeros instead of this times 10 to the 6 with it, but you can press SD on the scientific calculator and it'll give you times 10 to the power of 6. But it's asking us for the amount in tons. If we divide that by 1 times 10 to the power of 6, this number here, to convert it back to tons, that would be 68 tons. So you'd get 1 mark for working out this relative formula mass of ammonia here. You get 1 mark for doing this calculation here using this 2/3 ratio from that equation, and your final mark would be your answer in tons. So that's your 3 marks. Sarah makes ammonium sulfate from ammonia in a laboratory. This is her method. Add excess ammonia to dilute sulfuric acid in an evaporating basin. Boil the solution until it does not smell of ammonia. Cool the basin until crystals form in the solution. The crystals that form in the solution are impure, so it's not just ammonium sulfate crystals, there's ammonia on there as well. Describe what Sarah can do to get her pure ammonium sulfate crystals. So obviously those crystals that are in solution, the crystals can be separated from the solution by filtration. So filter the crystals from the solution. If you just write down filter, you'd get the mark. Once you've got the crystals separated, they might still be wet with some ammonia on the surface of the crystals, so she could wash the crystals and dry them. So if you just write wash, you'd get the mark, but I'm just going to write the full sentence. So that's your 2 marks. Ammonium sulfate can be mixed with other substances to make compound fertilizers. Suggest why compound fertilizers are better for farmers than pure ammonium sulfate. So ammonium sulfate, the compounds or the elements that they have that allow plants to grow are nitrogen and sulfur. Compound fertilizers have other elements that are useful for plants, such as potassium, phosphorus. So that's what you need to say. So if you just write down compound fertilizers have other elements, that's 1 mark. Or if you write compound fertilizers have potassium or phosphorus, that would give you the mark.